Hello and welcome to TidyX episode 177. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. Thanks for checking in with us again. TidyX episode 177. Uh, as always, be sure to like and subscribe. Questions, comments down below. And if you enjoy the show and would like to support our work, we do have a Patreon page. We're thankful for anything you'd like to give. That said, we are going to jump into episode 177. We had a viewer submitted question from Cohen MacDonald. Thank you, Cohen. This is a cool problem. We're going to be working with FIBA, which is international basketball. We're going to be working with the FIBA basketball data set. And Cohen had a question about taking a JSON file from a website that is provided by FIBA and using the play-by-play data to basically parse out who the lineup is at any given time on the court. And it's kind of a big JSON data dump. There's a lot of things to work through, but
Oh, it's massive.
we do have a solution here. There's a lot of stuff in this solution, and there's a lot of limitations because it's not really play-by-play data. It's sort of like event-to-event data.
Yes.
So we're going to go through a way to solve this and get the data into a format that Cohen would find useful.
Yep.
And then in ensuing episodes, we'll kind of go more in depth into some of the functions that were used and things that were written here, because there's a lot of, especially when working with JSON, we've done some episodes on JSON before. It's a lot of working with lists and kind
It's
of
like
like
it's
writing
kind of
custom
gummed up.
functions. And
You're kind of like
yeah,
pulling apart different things, and it's a little bit difficult to
yeah,
like the JSON object type makes a ton of sense for its use cases because it's incredibly flexible. You're able to store a lot of different data types all in a text representation and just ship it out. This is what a lot of APIs respond with is a JSON
yeah,
file because of its flexibility and because there's in most programming languages there's some sort of way to deal with them and there's some
yeah,
sort of way to represent them in the programming languages to then deal with them. But this JSON is a like it's just a data dump. It's just everything about this game right there. So it is not the most friendly for us to use in R, but we did figure out ways to do this. I also want to call out that Cohen did a great job of setting up what the problem is, what they're trying to do, giving us an example data set that they're working with, and also providing the script of what they tried already so that
yeah.
we can see oh, I like what they did here and use that. You'll actually see we have some comments of, hey, Cohen wrote this a good chunk of this code, we just modified it a little bit,
It
and so it made this a lot nicer to go through.
yeah, and it also helps us, by seeing what it is, what kind of end result he's trying to get to. If he's coding and he's like, okay, I'm stuck here, I can't get it to do this thing, and
Yeah,
so that's
yeah. So without further ado, 3 minutes in, let's get going.
here we
So
go.
we've got library tidyverse for our data manipulation needs. Library, we were originally using library header, HTTR, but I believe it's pronounced header, to get the JSON, but I actually realized we don't need to do that. Per for our looping needs, JSON light to deal with the JSON, and glue for some string manipulation that we do later on. So let's first identify and pull in that JSON. Cohen provided a game ID here for us to use, as well as the URL, which is FIBA live stats dot blah 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 blah. But here you enter in the game ID, and then it goes data.json. And so we're using the glue function to paste in the game ID right here, and then we're going to use the read lines function, which does allow us to reach out to the internet and read just straight text, pull all that down for us. And so we're going to use this game ID. Here, let me actually load all the libraries, load the game ID, and do read lines. And so now what we have here, it's going to throw us a warning message because it didn't end with a blank string. But this object right here is actually just a text representation of the JSON. So we're going to use the JSON light parse JSON function to parse it into an object we can actually work with. Because right now it's still just a string object that is. I mean, look at this. This is kind of do not want to deal with this. But what we can do is we can use parse JSON and then use the simplify vector equals true function. What this will do is it tells JSON light, hey, when you can, please don't just leave this all as a bunch of lists that I have to deal with later. Please try to simplify this as much as possible for me so that I don't have to do this later on in my processing. Now, in this situation, this worked for us. Not every situation will simplify vector actually make your life simple because it's having to make assumptions on object types and everything like that. So in this case, it did work because what it did is what we care about is the play-by-play entry. So excuse me, we were assigning this to FIBA game. We see that there's a bunch of different slots here in the data set here. So some of them are pretty easy to deal with, like game or clock. So I'm assuming this can be pulled while the game is running as well. And so here the game clock is 0, so it's no longer running. You can also get like period, again, assuming that this is while the game is running. You pull this information. And you can also get like officials. And officials is a much more complicated, it couldn't simplify this for us. So it's a much more complicated object for us still, but it's got information about all the different referees that were included. But again, we care about the quote play-by-play or PBP data set here. And oh boy, is it a doozy. It's kind of a pretty information dense bit of data frame here. So we've got game time, clock. Because this is an undocumented API, we don't really know what each one of these mean necessarily, but we can like infer. So like TNO, team number, period is the which period of the game, period type is it overtime or regular, player, action type, action number. So we have we kind of have to make some educated guesses here as to what's going on. But what we think we can infer is that if we take the play-by-play and arrange by action number, that should give us the series, the order in which events occurred in the game. And this is just all events. So we can, here we go. For, I guess, subtype, and here's action type. So game, period, jump ball, jump ball, jump ball, 2 points, rebound, 2 points, assist. So like every single thing that happens in the game, they record it. And then there's also some additional information in subtype. So Cohen wrote some code to pull out who the starters were for the game. Patrick, do you want to take us through how that worked?
Yep. So we've got our play-by-play data frame. We're going to filter. So the action type, as we just saw, goes through all of the actions that were occurring in the game. So like a shot, an assist, a steal, a turnover, etc. And we have this handy action type called substitution, which will be filled in with in or out whenever the player is going to leave the court or not, right? So that's the type of action that they'll go through. So to get the starters, we need the period type to be regular period, obviously, because we're not worried about overtime here. We just want to know who the starters for the game were. We're going to get the action type substitution, indicating that there was some sort of substitution that was made on the play. We're going to arrange by team number and action number. So each of these action types is numbered based on where they occurred within the game. So this helps us kind of get away from or skirt the issue of dealing with handling the clock, which is right now a character value, and trying to make that numeric and putting it in order. We could just use action number because everything's going in sort of this count fashion, counting up from 0 to n number of actions in a given game. Then we group by team number and player number, and we filter the row number equals 1. So the first player for each team when their row number equals 1 and when their subtype is out. And so what this is basically saying is, in order to start the game and have your first action be out, you had to have been the starter, because you wouldn't be subbed in. You're subbed out. You were on the court first. So in theory, if we run this, we should see that we get 10 rows. We get 5 per team, which everything looks like it checks out right here. So we're doing pretty good. Then we're going to ungroup this because it's a grouped function first. It was a grouped filter. We're going to ungroup that and we're just going to create a handy dandy player name, which is just going to concatenate their first name and their family name so that we just have that there. And then just do a little arrangement, arranging by team number and player number so that things are in order. And then just selecting team number and player number, because really all we care about are the 10 starters. And if this worked, which it did, we have the 10 starters and we have team number 1 and team number 2. There is some team keys, I think, in Cohen's original code.
Yeah.
He did have some team names that go along with these numbers, and you could certainly pull that out if you wanted to add that. We just didn't here for simplicity, but it'd be an easy sort of left join team number to get the name.
Yeah,
right?
it's just I felt at this time I like to keep things a little bit simpler.
Yeah.
And so I'm like, this way, if we leave it as team 1 and team 2, we can more generically apply this downstream to other game IDs.
Yeah.
If you start implementing things where you actually care about the specific team number and whatnot, or too early on, or the team name too early on, and then your variable names actually reflect that, that gets really annoying to deal with. But by leaving it as team 1 and team 2, it's more generic, and then we apply the team name later on at the very end. That's the reasoning behind it.
Yep.
So now we have
starters. And now we need to jump into getting every substitution.
Yeah, and that's a bit of the bear, and I think that's a little bit where Cohen might have been struggling a little. These next pieces are how we get to the answer of which team has which players in at what time. So we take this, again, the play-by-play data frame, that big, ugly thing. We then, again, make player name because I felt like this was the best place to do it. And then again, we filter on action type substitution to only get the substitutions that occur. Next, I want to reduce, again, this data set is stupid wide, and I want to reduce the number of variables that I need to care about to continue forward. So I selected a bunch of game state information, such as game time, clock, period type, action number, as well as team number, player name, and subtype. And so this tells us what's happening kind of in the game. This Tino tells us which team did it. Player name tells us which player's being affected or doing the thing. And then subtype tells us, is this a sub in or is this a sub out? And so what we can do is we can take a quick peek at this because this is a little bit easier to understand. And you can see, if I scroll up to the top here, if you have action number 37 for Kelly Olenek, Olenek, they're subbed out, and then in the next action, Nikhil was subbed in. And so we can tell that there's like a pairing between subbing in and subbing out as well for every action number. And again, the game time and clock and period are all identical for those cases. So what we can do then is group by game type, clock, period, sub period type, and team number to get all this information consistent and go, okay, we're going to split on all the unique instances of this, and we're going to map across, and so that converts it into a list, and then we're going to map across each one of those groups. And so I'll quickly show you what that looks like. Because then I won't go too in-depth in this map since we'll do that in the future here. But you can see that here we have these, at this game time, clock, that unique combination there. We have Isaac Bonga and Johans coming out, and Franz and Moritz going in. And so what we can do is we can create a tibble that has all that same game time information, the action for in and out, and which players are subbed in and out. We can bind it together and then arrange by team number and action number 1. And we can end up with this sub play-by-play data frame. So now we have this nice data frame that has all the game type information, which action numbers, and then who was subbed in and who was subbed out. Now this is important because now what we can do is we can actually construct from this, okay, we know the player that went in, we know the player that went out, and we know who the starters are. We can now go through all those play-by-play substitutions and reconstruct who was in and who was out in every single substitution. Patrick, do you kind of want to introduce us to this piece here?
Yep. So constructing the lineups over time, we create this list object, And within each element of this list, we have a tibble where action will equal 0. Game time is 10:00, which is basically the start of the game when it's period 1. Period type is regular. And then what we're going to do is we have team lineups 1 and 2. Those are going to be lists that are nested within the respective tibbles of the broader list. So it's like a
Yeah.
and so we have from the starters data set, we're going to throw in the player names for team number 1 into the team lineup 1 list, and the player names for team lineup 2 into the team 2 list. So if we run this,
Right here.
oh, there it is. Yep. So we have there, you can see we have a nice little tibble that is here. We're looking at list element 1 of the
Yep.
of the whole show, right? And you can see that we have the lineup starting at action 0, game time 10, period 1. So this is basically walking onto the court in regular period to start the game. And there's going to be 5 players, which we see character 5 in each of those lists.
Yeah. So now what we can do is we now know who is in at the start of the game, and now we can just iterate, and we have to do this as a for loop because state matters. Because we care about what happened in the prior version of this loop, we have to build it up step by step. I think that's the best way to do it for this situation. So what we're going to do is we're going to take lineup over time, assign that to current lineup row. So this is going to initialize it. And then now, for every entry in the sub PBB DF, so every row that exists here, we're going to pull out that row. So we have the substitution in here. So we're going to pull out this one row here and say, okay, which team is subbing in? So this is team number 1. We're going to say, okay, who's the current lineup? So we're going to take the current lineup row, get the team 1. So sub team is that there, lineup. So we're going to pull out the roster for the current lineup for team 1, assign it to current team lineup. Here, so let me just I1 just so that I can kind of step you through it. Boom, boom, boom. So sub team is team 1. Current lineup is the list of the players right now. Now we're going to do this kind of funky piece here. So what we're going to do first is do a set diff on the current team lineup, so this team here, and go, okay, out of substitution, who was subbed out? And do a set diff. So that'll remove Andreas from the lineup. Then we're going to concat in who's the new player. Who's the player that just got subbed in? And so if we do that, we can see that Isaac was added to the lineup. Now we don't necessarily have a record of who got subbed in and subbed out for which players, but we now have the list of the team that's in there at this time. And we're going to call that new lineup team. Now we're going to pull, again, all the game state information out of substitution that we want to, and then we're going to assign back in to the lineup, team 1 lineup, this new lineup that exists, and we're going to call that current lineup row. And then we're going to add a new record into lineup over time. So now it's a new list entry. And what we can do is we can boop, boop, boop. Now for every single entry in the play-by-play, we have a list entry here for all the different teams and their actions there. We're going to bind it together. And now we've got a data frame that has all this information on all the different players over time. We're good. We now have that information. Cohen's question has now been answered. Right? We now have the list of which players are in at what time. But Cohen also sent additional information about, well, what they want to do is make essentially a plot over time of which players are in and out at various times. But looking at the time that we've got right now, we're hitting 20 minutes, and what we're going to do is we're going to solve that next week. So with that, that's a cliffhanger. We don't do cliffhangers normally, so you know it's going to be good. It's kind of a fun plot.
Yeah.
And we're going to then have to get into some more complicated time manipulation type stuff. So we're going to save that for next week. You should definitely like and subscribe to this to TidyX so that you get notified when we post the next video. But with that, we're ending TidyX episode 177 on how do you pull out using purrr and some cool data manipulation to deal with some JSON files. So with that, as always, my name's Ellis Hughes. You can find me on various social media sites at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter on X at OSP Patrick. You can find the screencast on X at Tidy_explained. But best way to get in touch with us, like and subscribe on the YouTube channel, as Ellis said. And as always, if you'd like to donate to the show, we do have a Patreon page. We're grateful for anything you'd like to give. Stay tuned for the next week's episode where we delve into this JSON file a little bit deeper.
Thank you all so much and keep on exploring your world.